Okay, so we decided that we'll have a contiguous memory allocation. Whenever a process actually moves inside the RAM, at that point, the entire process will actually have a fixed amount of space, and all of these spaces, all the instructions will be stored one after the another. Okay, so there's two ways that we can do it. So what we can do it is we can actually have a fixed size partitioning. So what we do is we actually divide your RAM into fixed size partitions. And these are called frames. So what will happen is, let's say P1 comes and P2 comes and P3 comes, they will come over here and they will basically store, let's say P1 is of size 20, P2, I don't know, these are just random numbers. So P1 will come over here and it'll basically start executing from here. P2 will find a space over here and it'll start executing from here. So, and all of these are fixed size frames. Now there's a problem in this. The problem is that what happens that if there is a process which is bigger than the size of the frame, in that case, what will happen is that process will not be able to run. The second second problem that happens is that let's say P3 is of size 3 and the total amount of space that is available is size 50. So P3 will occupy only this much space, remaining space will be left empty. This is called fragmentation. This is called internal fragmentation. So if we have a fixed partitioning, then in that case, what happens is that there is an internal fragmentation. Another problem is that if the process size is bigger than the size of the frame, you will not be able to run the process. So that's called fixed partitioning. Generally, people don't use fixed partitioning nowadays. The second thing that people do is called variable partitioning. What is variable partitioning? Initially, let's assume, let's look at our RAM in a different way. So let's say this is our RAM. And what we have is, we actually have an entire empty space. This place is called hole. So a process comes, process is of, let's say, size 20. So what will happen is, the process P1 will come over here and it will occupy this space. And think about this space as a double linked list, so you can basically go front and back from there. So everything earlier was a hole, and now P1 actually comes in and it fits inside this, so your hole size actually became smaller. Then P2 comes, let's say P2 comes over here, and then P3 comes. So P1, P2, P3 have occupied their space. Now what happens is, let's say P2 completes its execution, and after that P2 completes its execution, it gives this space out. So now this part becomes a hole, and then this part was a hole too. So there's two holes right now. Then let's say P4 comes, so P4 will try to figure out where to fit inside these holes. So it'll look at all the holes and it'll try to fit inside it. So there are different ways in which we can actually figure out which hole to fit into. So the different ways is, one is called first fit. Second is called next fit. And the third is called best fit. And the fourth is called worst fit. Okay, so let's see what these things are. So first fit, what you will do is you'll actually have a pointer over here and you will go through your entire RAM and try to figure out a hole where you can fit it. So let's actually put some more processes in there. So let's say there's P4, let's say P5 is running over here, and we have our empty spaces, and these are our different holes. Okay, let's say P6 comes. What it will do is, based on the size of P6, it'll try to figure out, can P6 fit in here? No. P6 fit in here? Yes. It'll fit the process P6 in here and start executing. The whole size will basically become smaller. That's called first fit. Next fit is, if you don't start from the start, you basically, let's say last time you put P6 was over here, the next time it'll start from this location and it'll go through the P5 and then come back from P1. It's like a circular linked list. So that's called next fit. Best fit is, what you do is you go through all your holes and then try to figure out which hole your process will fit the best. That is called best fit. The worst fit is where you go through all your holes and figure out which hole you put your process in, which will actually leave the maximum amount of space available. So these are the four different kinds of ways in which you can fit your processes inside your different holes in the variable partitioning scheme. Which one is best? It actually depends on the process, the size that they take, and the sequence in which they come, and the sequence in which they get executed and going back. There's another problem that happens in the variable partitioning. In variable partitioning, what will happen is that, let's say this process continues over and over and over again, then what will happen is there will be small holes available throughout this entire space. If you take that entire space, it'll be more for a process to actually move in. But since these are not in contiguous memory location, you cannot allocate that space to a particular process. That is called external fragmentation. Okay, so variable partitioning suffers from external fragmentation, and the fixed partitioning suffers from internal fragmentation. So the problem for handling the external fragmentation, what you do is after a certain amount of time, when you actually have too many holes over there, you run an algorithm called a compaction algorithm. What that will do is it will move all the holes together at one place, and it will move all the processes at one particular location. But that compaction takes a really long time to execute, so it's not a good way of doing things. But still, it is better than the fixed partitioning, because in fixed partitioning, you don't have fixed amount of space, and you can basically run a process if there's a space available over there.